Welcome to our first lesson on magnetism. We'll be looking at different types of fields that we can get, under which obviously magnetic field will also fall. Now many of our everyday appliances do have magnets in them and do make use of the magnetic fields. Things like your big speakers, your cell phones, your navigation equipment, your computers, your bank cards that also has a small magnetic strip at the back, to name but a few that has specifically magnets in them. Now we're going to start looking again as to how do these magnets actually function. We're going to go back to forces. Forces can basically be broken down into two types of forces. Now in grade 11 you will discuss the forces in detail. But just for now, we're going to have contact forces and non-contact forces. Now that's exactly what the word says. Contact forces means that we are physically pushing or pulling an object and therefore are making contact with the object which we want to move. Non-contact forces means that they act over a distance. And therefore there doesn't need to be physical contact between the objects in order for a force to be applied. Now we will be actually looking at only 3 non-contact forces during your physical science syllabus from grade 10 to 12. Now those non-contact forces, as you might have guessed by now, is one of them gravitational force or gravity, electrostatic forces, and lastly magnetic forces. So those are the only 3 types of non-contact forces that you'll come across. And as said, there doesn't need to be physical contact between the objects in order for the forces that we've just mentioned to be exerted. Now each one of these 4 forces actually has got an area around them in which this force then will be applied. So that basically means if we have Earth, but we're very far out in space, where this gravitational force of Earth doesn't play a role anymore, then we won't have any gravitational pull on us. But if we come close to this sphere or this area around the Earth where the gravitational force do play a role, then we will be attracted towards the Earth. Now this kind of field we will also see with electrostatic forces. That means if I've got, for example, a positive charge, around this positive charge there's a specific area where we will have, if you've got a negative or another positive charge close by, that they might be attracted or being repelled away. But if they're very far from this area, then there won't be any forces whatsoever between the positive and the negative. The same goes for magnets. Magnets is actually one of our best examples. If we do have a magnet and we've got, let's say, a paper clip, if the paper clip is placed very far away from the magnet, then this paper clip will not move towards the magnet. But if we bring the paper clip a bit closer, we might see that it starts to move, and the more closer that we bring it, the quicker that it will move towards the magnet. So also around a magnet there's a specific area where these forces then apply. Now we will call these areas then fields. Now we will call these fields depending on the specific non-contact force a desired name. So if it's a gravitational force, we will call it the gravitational field. If it's the electrostatic force, it's the electric field. And if it's called due to the magnetic force, then it is a magnetic field. Now we're going to be discussing a few of the characteristics of each one of these fields. Let's start off with the magnetic field. Now first off, it's an invisible force that actually moves from north to south. Now invisible means that we cannot see it. And in a few of our lessons later on, we would see that this force is always going from north to south. Now because of this direction, it's then termed a vector, because we will have both either a weak or a strong magnet, which then indicates the size of this magnet, and then because it's got a direction from north to south, it's therefore a vector. And it will apply this force on all ferromagnetic substances. Now we are going to discuss the word ferromagnetic later a bit in detail. It basically just means any substance that is attracted to a magnet is called a ferromagnetic substance. So our magnets then apply a force on all ferromagnetic substances. This force has got a direction, always going from north to south, and it is an invisible force. Now if you look at our characteristics of our electric field, Now this is also invisible force that basically will be moving positive charges around. Now in our next few lessons after magnetism we will be discussing electrostatic forces, so then we'll do all of this in detail. Now also it has got a direction and therefore is still seen as a vector just like our magnetic field, and it will experience this electrostatic force on all charged objects. That basically means something that's either positively or negatively charged. Now our characteristics for our gravitational field, just like our other two forces, it's also invisible force, but it will pull all objects towards the center of the Earth. It's also seen as a vector because it's got a direction, as I said, always towards the center, and it always works straight down towards the center. And the last one, it will act on anything that has a mass. So any type of object, as long as it's got a mass, it will have a gravitational force working onto it towards the center of the Earth. Now let's go and classify things as magnetic and as non-magnetic materials. Now magnetic materials are always strongly attracted to magnets, and some typical examples of them would be iron as well as steel. Now steel though is an alloy, and an alloy means that it's made up usually of more than one metal. Now for steel situation it's actually made up of carbon and iron, but mostly it consists of iron. Now because it does consist of iron, steel is therefore magnetic. But the other impurities, which in this case is carbon, that's added to this steel to make the alloy, is though not seen as magnetic. But overall, because of the great amount of iron inside of the steel, it is then magnetic. So do remember, an alloy is anything that's usually made up of two or more metals that's combined. Another very important type of magnetic material is nickel as well as cobalt. Now obviously any other type of alloy containing nickel and cobalt will also be magnetic. So our basic main three types of elements is iron, nickel and cobalt, and then their respective alloys which contains these specific elements will then also be magnetic. Now all of these examples is then attracted towards magnets, and therefore they will be termed ferromagnetic. Now that just means that they are then strongly attracted towards magnets, and iron and steel can actually be magnetized so that they will become magnets themselves as well. Now all of these magnets, usually when they heated to around about 770 degrees Celsius, will then actually lose its magnetism. So if you do have a magnet, it's important not to let it get heated up too much, because then it will indeed lose its magnetism. Now our non-magnetic materials are all other substances that is not attracted to metals. So that will be things like aluminium or plastic or wood, any of those types, as well as any other element on the periodic table that is not attracted to a metal. That is not attracted to a magnet. Now the question which I would like you to go and attempt is to tell me which of the following substances will be magnetic, and obviously or non-magnetic. Steel. Secondly, a penny that's made up of cobalt and copper. And then thirdly, earrings that's made up of silver and gold. So first pause your player and attempt the question before you're going to be looking at the answer. Now our first one was given as steel. Steel, as I said, do contain iron. Iron is one of the very few substances that is magnetic, so therefore our steel will be magnetic. It will be attracted towards a magnet. Secondly, we were looking at a penny, that's basically a piece of coin that is made up of cobalt and of copper. Now copper on its own though is not magnetic, but cobalt is. That means it's basically an alloy of both cobalt and copper. And because it does contain cobalt, which is magnetic, this then would be seen as a magnetic substance. And lastly, we've got earrings that's made up of gold and silver. Now neither gold nor silver is actually magnetic, so therefore our earring will be non-magnetic, and will thus not be attracted to a magnet. Do take note though that many of your earrings that is plated silver or plated gold means that it actually contains nickel metal on the inside, and then they've just covered it with a layer of gold or silver. Now those ones will be magnetic because it contains the nickel on the inside of the earring. But if it's made up of pure silver and pure gold, then it will not be magnetic. Now in our next lesson, we will be discussing the magnetic poles.